Hey, fourth graders. So today we're going to talk about inverse operations. I want you to take a quick second. You've probably heard the word inverse before. What do you think it means? Maybe write your definition down on a scratch paper or your math notebook. All right, now that I've given you a second to think, I want to give you the most basic meaning of inverse would be opposite. One place you've seen a lot of inverse operations would be fact families. And you probably remember this from when you were younger. When you were in about first grade, they taught you 3 plus 7 equals 10. So 7 plus 3 equals 10. So 10 minus 7 equals 3, and 10 minus 3 equals 7. We've been working with fact families for a really long time. You might have seen a math mountain or fact triangle. I've heard of it called both different things. So 10, 3, and 7. Maybe you've seen it with 2 lines. Maybe you've seen it with 3 lines. So these fact triangles show us that all of these numbers are related. They're a family. I need 3 and 7 to make 10, but also if I take 7 away from 10, I have 3. They're inverse. They're the opposite. I can add them and subtract them, do opposite functions, and still get the same answer. But now that we're getting older, we're going to be working with a little bit bigger fact families, up into the thousands and such. So the first question for you today is, if I was to ask you, I'm going to leave this one just kind of as a question mark, as an unknown. So if I had, this is going to be a lot, 1,310 pennies in a jar and 2,057 nickels in a jar. And I asked you how many total coins are there. I want you to use this break apart drawing to try to solve this. Think of your fact families. We know that if I have 1,310 and 2,057, whatever comes together will be the total. I want you to take about a minute in your own notebook to go ahead and solve this. So we're working with 2 pieces here to create the total. These are called addends. These are the 2 numbers that added together create our total. So we have our addends, and then we know that the total of an addition problem is called a sum. So these 2 addends create the sum. We can do it with a break apart drawing, or we could also do it just the good old-fashioned way that we're used to. We're going to come up with this sum. So I will show you. I'm actually going to give it to you with a missing number first. Okay, so our total is missing. We need to solve for our total. I'm going to make sure everything's lined up really well. So I know that 0 plus 7 is 7. I know that 1 plus 5 is 6. 3 plus 0 is 3. 2 plus 1 is 3. So I know here that I have a total of 3,367 coins in total. A couple other ways this could be represented is if I gave you some unknown numbers here. Let me fix this up for you guys. So if I was to leave this part completely unknown, I know that I have 3,367 in total. I know that I have 1,310 pennies. And I know that I have 2,057 nickels. So we can leave it in this break apart method. Now that we have, and they call it break apart, fact mountain, fact triangle, depending on how you learned it, it's all the same thing. I could solve for this unknown number now, because I know that if I have 1,310 and I want to get to 3,367, my unknown here would be 2,057. But if I didn't have this fact family, I hadn't solved for this yet, one way I could solve for the opposite of addition would be subtraction, because they're inverse. So if I said, I have 1,310 pennies, I have some number of nickels, in total I have 3,367 coins, how many nickels do I have? Well, setting it up like this becomes real tricky. And if you pretend you didn't have this fact amount already solved for, you'd have to figure out a way to solve for those nickels. So the opposite of addition is always subtraction. So I could say I know that I have 3,367 coins. I already have 1,310 pennies accounted for. How many nickels do I have? Well, 7 minus 0 is 7, 6 minus 1 is 5, 3 minus 3 is 0, and 3 minus 1 is 2. So I have 2,057 nickels. So another way that I could do this is, let's say, I'm going to give you another inverse problem. I have 2,057 nickels plus some number of pennies, and altogether I have 3,367 coins. Well, same thing, to solve for your unknown addition, you can use subtraction. So I'd say, well, I know that I have 3,367 in total. 2,057 are accounted for with the nickels. And then I have 1,310 pennies. So once you get to know these I call them fact families, but I guess in this case we're calling them break aparts. Same thing. I know that if I have one, I can complete it with the other. So I can always double check my work. If I have a subtraction problem I'm feeling a little bit stuck on and I want to really double check, I check with the inverse, which is addition. So for example, if I have, let's say, 5,192 minus 341. And you're feeling pretty confident in your subtraction, so you would solve it the regular way. 2 minus 1 is 1. 9 minus 4 is 5. I can't take away 3 from 1. I don't have enough here. Or I can't take away 300 from 100. Got to go over and borrow. Bring over a group of 10. Now I can solve it. So I have 11 minus 3 is 8. Drop down my comma. 4,851. And if I'm looking at this going, I'm not 100% sure I have the correct answer, I can always double check it. So I could take my two add-ins in this case, 4,851 plus 341. And I should be able to get 5,192. Let's double check. 1 plus 1 is 2. 5 plus 4 is 9. 8 plus 3 is 11. Carry my 1. I got to drop my comma. 5,192. And again, this works when we use the break apart method here. So as you guys go through this today, you might see the break apart method. You might see one of them unknown. And know that if you have the total and one add-in, you can solve with subtraction. If you have two add-ins, 4,851, and the unknown sum, you can solve with addition, because these two together create this one. So again, your two add-ins here, if they're ever missing, solve with subtraction. It's always the inverse. Think of fact families from about 1st or 2nd grade when you were really learning your stuff. The same thing applies here no matter how big the numbers are. So you can use addition to solve for unknown subtraction. And then you can also use subtraction to solve for unknown addition. The inverses, the opposites, you can use to solve for each other.